Hello, Sauce here. I'm going to be talking about the relationship between position and velocity. I'm going to be using graphs to help. Position is a general idea. Problems involving position are contextual, and what we're concerned with is how far away an object is from a starting point or an origin. Height and distance are the same type of problem as position. Height implies that the position we care about is a vertical distance from a ground, and typically distance problems are a horizontal position from a starting point. Like a car that goes on a journey that starts at home and travels away, we might have a function, a position function, which calculates the distance during that travel. Velocity is the rate of change of position. So if we're in a car and we're driving away from home, our distance might change, might increase, but the rate at which the car is changing its distance is a distinct concept. And of course, we can read the speedometer of a car to read what that rate is. I'm going to graph a abstract situation of the position of an object moving as a function of time. The vertical variable p for position, horizontal variable t for time. If we consider that our starting point for our change in position is the origin, then increasing the position, as I've done on this graph over time, would be like walking or driving away from the starting point. If I include a horizontal piece, then this is, over time, no change in position because the position amount would not increase or decrease. This would model maybe standing still or being parked. I could increase my position again and notice that the slope of this linear piece is more intense. So this would be increasing position at a higher rate. In a smaller amount of time, the position went up faster. I'm going to include another little horizontal piece and then a decrease in position, another increase, and a decrease. This completes a position graph of an object, the object's distance from the starting point. And I'm going to compare that to a velocity graph. And when I make the velocity graph, I'm going to label the horizontal axis time, the vertical axis v for velocity, and the positions on these graphs correspond. So if I make a tick mark on the axis here, that's going to correspond to the very same time as here on my position graph. So the velocity graph that I'm going to make is directly related to the position graph. If I have a position that starts at the origin and goes up by 1 for every 1 increment of time, then the velocity can be said to be 1. It's constantly 1 during this interval of time because the position went constantly up at a slope of 1. Velocity is the slope of the position lines. So in this next interval of time, if my position did not change, didn't go up or down, position is represented by a horizontal line, then my velocity must be 0. If I don't change my position, if I stay still, then my velocity is 0. I can reflect that by including a constant 0 value in the velocity graph. And I had to overwrite my horizontal axis there, so I put it in bold. Let's take a look at this small interval of time in which the position went up quickly. So I had a change in position of approximately 2 boxes over a time interval of about a third. My velocity is higher than at this interval. And I might reflect that by having a very small interval of time with a much higher velocity. After that, I have another horizontal position. That means no change. And that means that my velocity must be 0. I'm standing still, or I'm in a parked car. The position graph on the time interval between these points here is negative. That means that I'm going back towards my starting point. The distance from any point to the position is decreased, to the starting point is decreasing. That means my velocity must be negative because I'm going backwards. It would be like putting the car in reverse and going backwards. So you'll see that when I draw the velocity graph at that interval of time, I'm below the x-axis, or I'm below the t-axis in the negatives. I'm at -1 velocity on that time interval. The slope of this line and this line are equal, but they're opposite in sign. The slope of this piece here is -1. The slope of this piece here is +1. And that's reflected in the velocity being -1 during this interval and a +1 here. The slope of this line is more intense and it's negative. For every 1 I go over, I go down 2. This piece has a slope of -2, and that means its velocity at that interval is -2. These graphs correspond to one another. It's the same context, but we're analyzing the situation in a different way. Position analyzes the distance from an origin as it changes, and the velocity analyzes how fast at different times that change is occurring. We can do this again. But this time, because it's possible, we are not going to begin with position information. We're going to start with velocity information and see what velocity has to say about position. I'm going to label a tick mark here 2 on the velocity axis. And I'm going to invent a change in velocity. I have a velocity of 1 on a time interval, then a velocity of -1, and a velocity of 2, then a velocity of 0, so I'm bolding that part of the horizontal axis, and then a velocity of -2. So we have an object that is moving, and what we know about it is how fast it's moving at different time intervals. I can use this information to create the position graph, just as I used the position graph to create the velocity graph before. But I'm going in the inverse direction this time. Now, I know in the first interval of time that I'm going to increase my position because my velocity is positive. I'm going to get further away from a starting point. But this velocity information does not tell me where I begin. I don't always need to begin at the origin. That's just a typical starting place, like we would change our position relative to home, or we would change our position relative to the starting line of a race. But this information here does not indicate where we start. And if we don't know where we're going to start, we could choose any place and still be correct. If I choose to start at a position that is 1 down or at -1, then increasing at a rate of 1 means that my position is going to increase by drawing a line segment at that time interval that has a slope of 1. On this next time interval, my velocity is -1, which means that my position is going to decrease at the rate of 1 per time period. My velocity changes and is 2. That's reflected in a slope of 2 during that time interval. When I have a velocity of 0, there is no change in position. And then when I have a slope of -2 for a time interval, I'm going to have a slope that goes down, slope of -2. In this example, we had velocity information, and we're able to use it to generate the position information that corresponds.